Okay, so I'll be taking your today's class and we'll be starting inverse trigonometric functions. Uh, it will be a CBSE class, not a JE class. And we will be doing theory part and then questions, and then you will have to do some homework. So your regular teacher is right now not available to take your CBSE class. That's why I'm taking it. So this is a small chapter. We won't say too small, but yeah, compared to functions, it is a small chapter. And when we talk about inverse trigonometric function, so it is actually inverse function. So inverse function for any function which is whose inverse exists. So for that, the function needs to be bijective. So do we remember what is bijective? That means it is 1 1 and onto. 1 1 is injective, onto is surjective. So if we see trigonometric functions, okay, Austin, no issue. If you have not done relations, then also you will be able to follow. So when we see a function, for example, sine function, sine x. So okay, so sine x function is like this, and this goes from minus infinity to plus infinity. It never stops. Its maximum value is 1 and minimum value is -1. So is this function a 1 1 and onto function? If we want to understand about this function, like if we take sine of x is equal to half. So we all know that x could be pi by 6, which is called 30 degree, or 5 pi by 6. And similarly, many other values. There will be negative value, positive value. So this is half, and you will get here pi by 6 also. You will get 5 pi by 6 also, and many other values, infinite values. This value is 2 pi plus pi by 6, plus 2 pi plus 5 pi by 6. On left, when you will go, again you will find minus pi by 6. So there are many values. So this is a many one function. And what about whether it is onto function or into function? So this is not a onto function, it is into function. Why it is into? Because its range is -1 to 1. And codomain we are taking as real number because it is not mentioned. So we take real number. So it is also into function. So both the criteria which is to be there is not being satisfied by the sin x function. So how do we find its inverse? So if you want to find it inverse, we have to first change this function from many 1 to 1 1 and from into to onto. So how we will do that? Let us see. But first write this down. Madiha, you joined a little late. Just write this down. This is what we have started with.
Okay, sir.
If you have done writing, then tell me. We'll proceed. Okay, Madiha, you have done it. So our task is to change this many one function and into function into one and onto. So if we want to do this, what we will do, we will first define sin x as a function fx, where f is some restricted domain to some restricted codomain. So what we will do, we will take the branch of this sin x, which covers all the values from -1 to 1 once. So if we select this branch, this am I highlighting here, this branch of sin x, and neglect the further branches, whether it is on the right or on the left, we will see that this function becomes 1, 1. So what we are doing, we are taking a value -pi/2, where it is -1, to pi/2, where it is 1. So we restrict the domain from -pi/2 to pi/2. And also the codomain we take same as the range, -1, 1, not the real number. So when we will do this, we'll select that portion. The graph would be of sin x, something like this, that it is a function and it goes like this, it goes like this. So this is 0, this is pi/2, which is -pi/2. This value is 1, this value is -1. So we are defining fx equal to sin x in this region only. Now this changes into a 1, 1 and onto function because values are not repeating and its range is same as the codomain. So this is what change we will do in the normal sine function, and we'll say that it is a bijective function now. Now, if we got the bijective function, like if it is written that this is the sin x function, and you are asked to find Okay, Madiha is saying what 1 1 is. 1 1 means for one image you have one pre-image, whereas many one means for one image you have many pre-images. So as you can say in above graph, for one image that is half, you have multiple pre-images, 5 by 6 also, 5 by 6 also, and all other values. But for for one image, you get only one pre-image. Madiha, is this clear?
Yes, sir.
So this is now having only one pre-image for every image. So now someone says, what is sine x is equal to half? So you will say that x is equal to pi by 6 only. You won't say all other values because the parts of the sine x function you have truncated from here. So this is minus pi by 2 to pi by 2, where both are included, is called principal value region of sine x. This is called the principal value region of sine x. Now, if you want to define sine inverse x, so what will happen? We take y is equal to sine x. First, write till here.
Sir,
Yes,
here for value 1 to minus 1, we are selecting one branch.
yes, yes. That branch is the principal value region of sin x, or sometimes it is also called principal value branch of sin x, or principal value graph of sin x. Written everyone? Everyone has written it?
So
I
one.
hope. Okay.
Yes.
Okay. So now we want to find the inverse of this function. So generally the method of finding inverse is that we take y is equal to sine x as the function and then write x as sine inverse of y and then replace x by y and y by x. So interchange x and y. So this will be y is equal to sine inverse of x. Or the inverse function somehow we write it f inverse x is equal to sine inverse x. So this simply means that if you have sine of pi by 6 is equal to half, that is sine of 60 degree, 30 degree is half, then it means that sine inverse of half is equal to pi by 6. So this is the inverse function. That means in the normal function, if you talk about the function sine pi by 6, so in that function, we have the input as angle. So in y is equal to sine x, we find that x is an angle and y is a value between -1 and 1. Whereas in y is equal to sine inverse x is a value and y is an angle. So that is why when we say that a function fx is equal to sine inverse of x, let us call it gx because fx is we are taking sine x, so this is gx. So we say that this g function is from -1, 1 to minus pi by 2, pi by 2. That is the domain and the codomain reverses. As you can see there that in sine x, what we took here is that our domain was the angle and our codomain was the value. Whereas in the inverse function, we can see that our domain is the value and the codomain is the angle. So this is sine inverse x. Now we'll draw the graph of sine inverse x. First write this down.
Sir, inverse means the opposite.
Yes, what are you asking?
Inverse means opposite.
Yeah, in rough language, you can say that it is opposite. But inverse actually means that the codomain and the domain interchanges. So whatever is the input in the function, in the inverse function, it will be the
It will be
output.
output.
Yeah. And whatever is the output in the function, it will become input in the inverse function. If you have written this, I will give you a question, but before that, I will draw the graph of sine inverse x. So have you done it?
Can you repeat, sir?
Yes.
Have you written it down, every one of you?
Yes.
Okay. So what happens that if you get a graph of sine x, which is like this, and you draw a line y equal to x, which is like this. This is y equal to x, and this is y equal to sine x. So when you draw the graph of sine inverse x, so the graph would be mirror image function and its inverse function. Our mirror image about the line y equal to x. So the sine inverse x graph will be like this. 1 second. Yeah. So it would be like this. So this is y equal to sine inverse of x. So if you see that there is a point here where x is pi by 2, you are getting sine x as 1. Then here at 1, you will get the value of sine inverse x as pi by 2. The role reverses. Okay. So because we know that here the input is the value and output is the angle. So this will be the graph of sine inverse x. Now, if you separately want to draw it, then you can draw it like this. So this is y equal to sine inverse x. This value is 1. This value is pi by 2. And this value is -1. And this value is minus pi by 2. This is the origin. So you can draw this. Have you written it?
Sir, can you explain?
Who is asking?
Sir, Amit, sorry.
Sorry, I can't hear you clearly.
Sir, can you explain it again?
Okay. So the graph of y is equal to sine x, which we took between minus pi by 2 to pi by 2 was this one. This is y equal to sine x. And we draw the graph of y is equal to sine inverse x, which is mirror image of this graph about the line y equal to x. So if you draw something which is mirror image of this, so it would be like this. So this is y is equal to sine inverse of x. Now, as we know that sine inverse take values as the input. So it will take 1 and give you the output pi by 2, which is 90 degree. And it will take minus 1 and give you the output minus pi by 2, which is minus 90 degree. Is it okay?
Yes, sir.
Sir, here domain is on y-axis.
No, domain is always on the x-axis. So this will be the domain will on the x-axis and codomain on the y. Like if I give you a question, suppose sine inverse of minus root 3 upon 2. So what will you give the answer of this? At
Minus sine
what?
inverse.
Sorry.
Minus sine inverse.
Sure. What is the final angle? What angle will you get?
60 degree.
60 degree.
Sorry, 120.
Yeah, that not 120 degree. Actually, the angle for sine inverse, we know that we can take minus 1 to 1 to minus pi by 2 to pi by 2. So the angle which will come will be between minus pi by 2 to pi by 2. That is minus 90 degree to 90 degree. So we can't go beyond 90 degree or before minus 90 degree.
Okay.
So 60.
But at 60 degree, we get root 3 by 2. This is minus root 3 by 2.
Minus 60.
Yeah, minus 60. That is minus pi by 3. So this will be our answer. So this is how we will see that how the inverse function gives you the angle. Because we have to keep in mind the principal value region always. Our answer should lie in the principal value region. We can here explain also because sine of minus pi by 3 is equal to minus sine pi by 3, and this is equal to minus root 3 by 2. So that's why we can say sine inverse of minus root 3 by 2 is minus pi by 3. And if I give you a question like sine inverse of 1, what will it be? Hmm?
90 degree.
Sorry.
90 degree.
Yeah, pi by 2. Always give answer in radian because generally we do the calculations in radian inverse in inverse trigonometry. Now we come to cos graph. This is the sine inverse and cos inverse we will see. So in cos inverse, what happens? We know that the normal cos graph is something like this. It is same as sine graph, but shifted by 90 degree to the left. So it is 1, this is -1, this is pi by 2, this is pi, this is minus pi by 2, like this. Now, if you want to change this function from many one as it is many one, as you can clearly see that a value will have many pre-images because it is starting from minus infinity to plus infinity, and it is also into because its range is -1 to 1, whereas its codomain is real number. So many one and into to 1 and onto. So which branch should we select? What will be the principal value branch?
Minus pi by 2 to pi.
Minus pi by 2 to
Pi.
pi. Okay. Let us suppose we select this branch minus pi by 2 to pi. So it is many one here. It is not 1 because if you see, this is having two pre-images. If you take a value half, half is equal to cos x, you will get x as pi by 3 as well as minus pi by 3 because minus pi by 3 also give you positive value in cos. So should we take minus pi by 2 to pi?
No, sir.
So we can't take minus pi to pi, na? So which region we have to take finally? Just think about it. In general term, you can understand it like that, that the region should cover all the values from -1 to 1, and it should cover these values once only. It has to cover all the values from -1 to 1, and it has to cover it once only. So should I tell?
Yes.
So we will take this branch 0 to pi. When we will take this branch, we will see that all the values from -1 to 1 are covered. Like this. All the values from -1 to 1 are covered from 0 to pi, and they are covered once. So what we will do, we will take cos x 0 to pi, 2 minus 1 to 1, and this will become 1, 1 and on 2. So this is the cos x graph. This point where it is intersecting the x-axis is pi by 2. Just write this down. Yes, written. Okay, so I hope you have written it. Now, if you want to draw the cos inverse x graph, so what you will do, cos x graph, you know that it is like this. This is 0, this is pi by 2, this is pi, this is 1, this is minus 1. This is cos x. Now draw a line y is equal to x. So this line is y is equal to x. And you take the mirror image about y equal to x. When you take the mirror image, it will be like this. It will be like this. This value will be pi. This value will be pi by 2. And this value is 1. And this value is minus 1. So they will intersect on the line y is equal to x. This is cos inverse x graph. So green one is the cos inverse x graph and blue one is the cos x graph. They are intersecting on the line y is equal to x somewhere. And you can say that cos inverse x will have the domain minus 1 to 1 and codomain 0 to pi. So if you suppose take cos inverse of 1 by root 2, what will you get? Sorry.
45.
Yeah, 45 degrees, which is pi by 4. Now, if it is cos inverse minus 1 by root 2,
minus
Not
5 by
if-
4.
No, not minus 5, 4, because here the principal value
Not
region,
defined.
sorry,
Not defined.
no, it will be defined. The principal value region is 0 to pi. So you have to search for the angle from 0 to 180 degree. So that value will be 135 degree. That is 3 pi by 4. Because we know that cos of 135 degree, that is 3 pi by 4, is equal to, so we have to search in the principal value range, which is 180 minus 45, which is written as minus cos 45, which is minus 1 by root 2 by allied angle rule. So this is how we will get the, this you have written now, this, yeah, this will, this. Now you can write this. So in case of sine inverse, you will look between minus pi by 2 to pi by 2. In case of cos inverse, you will look between 0 to pi, because sine inverse principal value is between minus pi by 2, pi by 2, and cos inverse principal value is 0 to pi.
Sir, if it is not coming between 0 to pi, so you have to solve and check.
Sorry, if it is not coming between 0 to pi, then
You have to solve and check.
yeah, you'll have to solve and check. That is what you have to see, that the value must be between 0 to pi. If it is not in, if suppose someone takes cos inverse of 2, so it is not defined because it is not in the domain, 2 is not in the domain, but minus 1 by root 2 is in the domain, minus 1 to 1. So that must give some angle. Write this down. I'm coming in a minute from washroom. Yes, have you written it?
Yes, sir.
Okay. Now next is tan. Next trigonometric function is tan. So if we talk about tan x graph, so it is from minus infinity to plus infinity. At 90 degree, it is not defined, which is pi by 2. This almost becomes parallel. And at minus pi by 2 is also not defined. This is the origin. Then again from pi by 2 to 3 pi by 2, it will be like this. And this is pi. So this keeps on going. On the left also, it will be like this. So this is the y-axis. So it is also a periodic graph. Tan x is also a periodic graph. Now it is many one but it is onto. Tan x is luckily onto because tan x is having domain as real number except 2n plus 1 pi by 2, that is odd multiple of 90 degree. There it is not defined. 2r, that is its codomain. Codomain is minus infinity to infinity. So though it is many one and it is not into, it is onto. So one criteria it satisfies, that it is onto. In earlier two cases, what we saw that it was into. Now, which portion we need to select to make it 1, 1?
Sir,
Yeah.
what is the meaning of onto?
Onto means that codomain is equal to range. So as you can see, the codomain here is R, real number. And range is also real number because it is taking the values from minus infinity to plus infinity. In earlier cases, like in cos, our codomain was -1 to 1. What we were getting was that its codomain was -1 to 1. Okay. So we had to restrict our codomain to -1 to 1. It was not real number. So if we want to make it 1, 1, what we need to do? Which branch we need to select? Yeah, any idea? Anyone can give any input? So let us take this branch. So if we take only this one branch, so it will be 1, 1, and onto it is already there. So we will take tan x, not this one, but minus pi by 2 to pi by 2 only to r. So this will make it 1, 1. Earlier one was many one. So first write this down, then we'll see the graph of tan inverse x also. written. So if you see the tan x graph,
So 1 minute, sir.
okay.
Yes, sir.
Okay. So if you see the tan x graph, it is like this. And if you take the line y equal to x, it is like this. So if you take tan inverse of x, it will be like this. So it will be almost parallel to the line y equal to pi by 2 and also to the line y equal to minus pi by 2. This is origin. This is x-axis. This is y-axis. So tan inverse x, if you see that green curve, so it is a real number to minus pi by 2 to pi by 2. One thing just keep in mind that minus pi by 2, yeah,
Sir, here in tan x, what is the code?
real number.
So the minus infinity to infinity.
Yes, yes. So one thing you have to keep in mind that the principal value region of tan is minus pi by 2 to pi by 2. And minus pi by 2 and pi by 2 are not included. It is open. Though the sin x was also minus pi by 2 to pi by 2. If you see, we did in sin x that it was also minus pi by 2 to pi by 2, but it was included. But here, it is not included because tan is not defined at minus pi by 2 and pi by 2. So just write this down. And also solve this question. Tan inverse of 1 by root 3 is equal to kya? What will it be? And tan inverse of minus root 3, what will it be? First write, then solve. Okay, Mohammed Sharif has given the answer that for the first one, it is tan minus pi by 30. It cannot be 30 now. It can be 3. So minus pi by, it won't be minus pi by 30 or minus pi by 3 also. It is still wrong. Second one also, Mohammed Sharif, it is wrong. Because 1 by root 3 we get at which angle? Can you tell me? In terms of degree only, can you tell me?
Pi by 6.
Pi by 6, that is 30 degree. Is 30 degree. 180 by 30 is 6. So we won't write 180 by 30, we will write 180 by 6, that is 30 degree. And minus root 3, what will it be?
Minus 60.
Yeah, minus 60, that is minus pi by 3. Because we have to see in this region, minus pi by 2 to pi by 2.
Sir, here minus pi by 3 is more less than minus pi by 2, right?
It is greater than minus pi by 2. Minus pi by 2 is minus 90 degree, no? Minus 60 degree is greater than minus 90 degree. Now let us come to reciprocal trigonometric function. So we first come to cosec x. So cosec x, again, if you want to see the graph of cosec x, it is like this. And then like this. So this is cosec x. And if you want to see the values where it is not defined, those values are 0, pi, minus pi, because sine is 0 now. So cosec x is actually 1 by sine x. So if sine x is 0, cosec x will be undefined. And its value is 1 limited here, minus 1 here. So if you want to make it 1, 1 and onto, what you will do, right now it is not 1, 1 and onto. So you will change the codomain to minus infinity comma minus 1 union 1 comma infinity. These values it will give, not all real number. The values between minus 1 to 1 it will not give. And the region which you will select will be this one, this one. So this will give you 1, 1. So this value is pi by 2. This value is minus pi by 2. So you will take minus pi by 2 to pi by 2, but you won't take 0 in between. 0, it is not defined, so you will eliminate 0. Or you can write this also like this, minus pi by 2 to pi by 2, except 0 to real number except minus 1 comma 1. So if you draw the graph of cosec inverse x, so what you will do that you will draw it like this. And you will draw it like this. So this is cosec inverse x. As you can see that in above 1, pi by 2 you are getting 1. So here at 1 you will get pi by 2. And as it is going towards infinity along y, here it will go to infinity along x. And here at -1, it is minus pi by 2. This is the origin. So cosec inverse x, when you will write real number except -1 comma 1 to minus pi by 2 comma pi by 2 except 0. So the domain and codomain will interchange of cosec x and cosec inverse x. Just tell me when you will note it down. Austin is saying, what is that -0? That is actually we are not taking 0 into consideration in the codomain because this graph is not touching or intersecting the x-axis. So 0 we have to eliminate. So here we have eliminated 0. So that is why here also we have eliminated 0. At 0, the cosec x is not defined. Cosec x is not defined at x is equal to 0 because sine 0 is 0 and it is the reciprocal. So this is the principal value region, right? This is the principal value region of cosec x. So let us see for sec x. I hope you have written this. Everyone has written this. So sec x graph, as we know, is again like cosec x, but shifted by pi by 2. So it is like this, and like this, and like this, and like this. And this is the line where it is not defined. This is pi by 2, then 3 pi by 2. These are the points where sec x is not defined. Then at minus pi by 2, minus 3 pi by 2, because their cos x is 0 now. Sec x is 1 by cos x. If cos x is 0, sec x will be undefined. Its value is also not between minus 1 and 1. Its value is either more than 1 or less than minus 1. So if you want to select the region which is 1, 1 and on 2, so what you will do, can you tell me which branch you will select? So if you want to make it 1, 1 and on 2, you will take this part and this part. So just like cos also, so sec x will be 0 to pi except pi by 2. Because at pi by 2 it is not defined, to minus infinity comma minus 1 union 1 comma infinity as it was in cosec x. Or you can also say that sec x is 0 to pi except pi by 2 to real number except between minus 1 to 1. So both is same. And when you draw the curve of sec inverse x, this is sec x, first write this down. So when you draw the sec inverse graph, you'll take the mirror image of sec x about y equal to x. So as we have seen that sec x is this one. This is sec x, we have highlighted above. And we take a line y equal to x. So it would be 0, 1. So 1, 0 and pi by 2 infinity. So it would be like this. And this portion would be like this. Yeah. So this graph, which is the red graph, that is the graph of sec inverse x. And black graph is the graph of sec x. So if you want to draw it separately, you can draw it like this, that it is like this, and then like this. So this is a line y equal to pi by 2, and this is 1, this is -1, this is 5. This is the graph of sec inverse x separately. And if you combined draw in the same graph, you will see black one is the sec x and the red one is sec inverse x. So sec inverse x is r except -1 to 1 to 0 to pi except pi by 2. I hope you have written it down. Now we come to the last one, that is cot inverse x. So you have to remember the graphs and more importantly, the principal value. Which
So
is
just so you know,
okay.
Yes, sir.
Yes, written. Should we move to cot?
Yes, sir.
Okay. So cot x graph, which is actually reciprocal of tan x. So it is like this. And the values where it is not defined is the values where tan is 0. So tan is 0 at minus pi, 0, and then at pi, then at 2 pi. So there the cot is not defined. So this is cot x graph. Now, if you see the codomain, it is real. So we don't have to do anything in codomain. But the domain, if you want to take, so if you want to make it 1, 1, so what should be the domain that we should take? So can we take this part, this branch? 0 to pi, open. So we take this and truncate all other branches. So in that case, if you see cot inverse x, it will be real to 0 comma pi. So when you draw the graph of cot inverse x, it will be the mirror image about y equal to x line. So cot x is this one, and you have this line y is equal to x, and then cot inverse x, if you will draw, then it will be like this. So this red one is cot inverse x, and this black one is cot x. And they are mirror image about the line y equal to x. They are intersecting also on y equal to x. So these are all very basic and important part of inverse trigonometric functions. There are many properties which we will study in the further classes, but we need to understand these first. And the concept of principal value is very important, because in any question, if you have to find the angle of any value, then you have to find the principal value angle, not any angle. So you should know that what is the principal value region of all these 6 inverse trigonometric functions.
Sir, principal value means one input for every function.
This is like here it is 0 comma pi. The angle,
Okay.
which is actually domain of the trigonometric function, or codomain of the inverse trigonometry function. Have you written?
Yes.
Okay, so let us. Someone, sir, can you explain sec x graph? Yeah, sec x graph. What we did here is this was the sec x graph. No, so in this is reciprocal of cos x. So this sec x graph, we take the region which is 0 to pi except pi by 2. And that is the principal value region. This region is the principal value region. The shaded area, which I have highlighted. And then from there, we have got the sec inverse x. That is the mirror image of y equal to x line. So in sec inverse, the input now is, what was the output here? That is the input now. And what was the input there? That is the output now. And rest is graphical part. So in exactly what you want to ask here. Yes, Sarif.
Nothing, sir. I just had a doubt in the graph.
What doubt? Is it clear?
Yes, sir. Clear.
Okay.